Hey y'all, Kyle, AA0Z here. Wanted to do a quick video about Ser2Net and how I use this in my station. Got a few emails and comments about how this actually works. So let's get into how this program actually helps connect some of the serial ports to network. Ser2Net is all it is a media converter. It converts your serial devices to network devices. And you can do this with a Raspberry Pi. You can do this anything that runs Linux. So I'm going to show you, if you don't have Ser2Net installed, you can install it by, I've got a terminal session up here to my Raspberry Pi, and you can do a sudo app-get install Ser2Net and hit enter, and it will install the latest version of Ser2Net. I would accept any defaults that it needs to install to get that up and running. But once it's done, we are going to configure it, but I want to first go over my configuration here. So I've got the Raspberry Pi here that is the heart of the system here. It runs Ser2Net, and I've got a couple of different trip-light hubs, USB hubs, that are plugged into the USB ports, and each one of these provides, I think, 7 ports, and then you have to provide it 12 to 20 volts power. Each one of these hubs is connected to a series of boxes. In our case, we've got these EA4TX boxes, and one of them is the remote box, and that switches the 6-pack 2x6 antenna switch. Then we've got the ARS USB azimuth rotator controllers, and we've got 3 of those. Then we've got another USB hub down here, and these are connected to the 3 WA4 MCM switches that actually switch the antennas at the base of the tower. These control boxes have USB on the out of the back of them, and they connect into the trip-light USB hub, and then the coax gets connected into this bias T, and then the actual 4-port switch is out at the base of the tower, and it switches via coax, positive DC, negative DC, no DC, or AC, and that's how it switches those 4 positions. So again, this Pi is running Ser2Net. And then here are some of the ports that I have configured on my Ser2Net configuration, and we will talk about this configuration. So the admin port is port 8000. The remote box is TCP port 8001, so it's this box. The ARS towers are 8002, 3, and 4, so that's these. And then the MCM switches are port 8005, 8006, and 8007. Okay, so let's come in and take a look at the Ser2Net configuration. So I've already got it installed on this Pi, and I'm SSH'd into it. So if I go to etc ser2net.yaml, YAML, that's where the configuration is kept, is etc/ser2net YAML. I'm sorry, we're going to C to etc, and then we're going to do a sudo nano ser2net YAML. And here is my Ser2Net configuration, okay? So on the default configuration, I didn't do anything. I just left it as is and just added some stuff to it. This admin is admin configuration here says an acceptor, so it's going to accept connections through TCP on port 8000. And I'm going to show you how to get into this port. All these ports are telnet. There's no security on them. So if you telnetted to port 8000 on your Raspberry Pi, you'd be able to monitor the TCP port or the serial port on each one of your connections, okay? So here is a connection. So you started with an AND symbol, and then I named this antenna switch. So this is this remote box. which is the antenna relay. So it's called antenna switch. The acceptor is TCP port 8001. I've enabled it, and here are the options. The options are I can connect at least 4 different connections through this device. So if you've got Node-RED running, so that's one device. If you got maybe a Windows program that controls this device, that's a second connection. So just keep in mind, I think the default is 1, so you probably want to bump this up if you're going to connect to from different operating systems or programs into your serial device. Then this connector, it says I'm connecting this through the serial device, and then here is my device ID, and I'm going to show you how to get that. And then here are the things that you're familiar with. 38,400 is the speed. N8 and 1, I forget off the top of my head, stop bits and polarity and all that stuff. So that is that. What you can do is you can go into the Ser2Net configuration guide and figure out which things you need to set here. And then it just says that the serial device is a local device. So if I scroll through this configuration guide, you'll see that I've got antenna switch, I've got ASR tower 1, ASR tower 2, ASR tower 3, and then I've got the RAAST tower 1, and that is the antenna switches that are at the base of the tower. So that's RAAST1, RAAST2, RAAST3. And then I think that these are actually the default settings of the YAML file. Yeah, so that is the configuration. So we're going to get out of this, hit Control X. So in order to identify your device IDs, that is kept in CD dev serial. And then if I do an ls, there's 2 folders here, by ID and by path. I like to go into the by ID. And if I do an ls, you'll see that all of my devices are here. So I've got my EA4TX boxes here, and this Silicon Labs is the WA4MCM boxes that have been plugged in. So each one of these has a unique ID, and then you can figure out which one these are after you plug them in. You can do a demessage. And once you plug that in, your new serial device, it will come down here and show you what that serial device is. And it will give usually a serial number. So then you can take that serial number and you can search that serial number and that manufacturer or what it identifies as part of this ID. So then what you want to do is you want to take that ID, that whole path, and you want to put it into, Ser2Net. You want to put that into this path right here. You can see it's dev, serial, by ID, and then USB EA4TX serial 22465 IF00. So that's where that goes with a comma at the end. So then after you get all of those done, or that configured, then you want to restart Ser2Net. So you do a sudo systemctl restart ser2net.service, and that should restart the service. And you want this service to start up whenever you start your Pi. So in order to start the service, you want to ensure that it's enabled and you want to start it. So that command is sudo systemctl enable Ser2Net service, and that will enable the service. And then you want to start it, which is sudo systemctl start Ser2Net service. So that is how you start, stop, restart, and enable the service on Ser2Net. All right, here is the group's IO post that I put together about how to install Ser2Net, how to configure the YAML file, how to restart it, and then also you can issue this netstat-l, and it will tell you all of the ports that are listening on your Raspberry Pi, your TCP ports. So therefore, you should see the ones that you open through the Ser2Net configuration file. You should see those. There's also a bug that I have seen in Ser2Net where the Ser2Net service starts before networking starts, and you got to make sure that that does not happen. So in the lib systemd system ser2net.service, you need to make sure that the service starts after networking. So you want to make sure that your service file looks exactly like this to ensure that that doesn't happen to you, because I've had that happen and it just didn't work. So here is a whole article about Ser2Net, again, on the group's IO for ham radio. If you got any questions, I would search this thread out and ask your questions there. But some more information out there. If this video didn't work for you, maybe you can get some information from the group's IO here. All right, I'm going to show you how to monitor the connections on each side of the Ser2Net program. So what we're going to do is we're going to telnet into port 8000 into the Raspberry Pi that we are running Ser2Net on. So we're going to do telnet, and then we do open 192.168.100.19 and then space port 8000. So now it's going to give us a prompt here. So we are telnetted into the Raspberry Pi that is running Ser2Net. So we want to, let's say we want to monitor port 8001 coming in from the TCP side. So we would type in monitor and then TCP and then the name of the connection. So that was ANTSWT. And you can see that I'm sending it an S. And you can see those S's that are coming into to the Pi on the TCP side, okay? So to stop, you type in monitor, O-N-I-T-O-R, stop, and it will stop the monitor. I didn't spell it right. M-O-N-I-T-O-R-S-T-O-P. There we go. So in order to monitor the serial side, we'll do monitor term ANTSWT without the ampersand. Okay. So this is what, after we send the S, that is what is coming back into Node Red and being parsed of what antenna ports are selected on the remote box, okay? So to stop this, M-O-N-I-T-O-R, stop. So let's try another one. Monitor, M-O-N-I-T-O-R, and then we want TCP and ARR-AAST1. So it looks like it's sending an A question mark and an M question mark over and over and over. So on the term side, monitor terminal or term RAAST1. it's sending, so we're requesting the antenna, and it's saying that it's on antenna 3, and MA means that it's in manual mode. So it's sending actually two things, and I'm parsing out if it's a or if it's an M. So basically tell me what antenna and what mode it's in. So we're going to stop this, MONITOR, stop. And then to exit out. So that is how you can monitor each side of the TCP or the terminal connection through Ser2Net. All right, that is it from this side. I hope that this was informational for you. And if you have any questions, leave them in the comments below. And we will see you on the next video, 73.